All right, everybody. I think it's time to get started. Thank you for putting up with the delay. I think we'll still have a few stragglers come in, but we should probably get going. My name is Mary Halley. I work for WSP. It's an environmental engineering and infrastructure company. If you've heard in the past of AMEC or Ogden or AMEC Foster Wheeler or Wood, all of those were WSP before we became WSP a few years ago. So I have worked for the city of Johnson City, the city of Elizabethton, the city of Bristol for many years. I've also worked for Kingsport off and on throughout those years. And I'm representing all four of those communities today for this Stormwater Quality Design Seminar. I assisted the communities with revising their ordinances and revising the water quality, what used to be the water quality BMP manual to now the water quality SCM manual. And we're here to talk about those revisions so you can kind of learn what's different. Before I get started, just a few announcements. Feel free to get up and use the restroom, get refreshments, whatever you need. If you need to use the restroom, if you go out the doors, any of the three doors, just look to your right. The restrooms are all the way over on your right. Egress, I didn't ask, but I think probably the best way down is to go left and down the stairs that are down to the left and out the building. Don't take the elevator if you can get away from it. Let's see, be sure to sign in. Even if you didn't register, sign-in sheets are back to the left, and make sure that you indicate whether or not you want a PDH certificate. One of us will be emailing those certificates out sometime in the next several weeks. Go ahead and contact me. I was the person on the invitation whose email was on the invitation. You're welcome to contact me if you didn't get your certificate. And if I'm not the one sending them out, I'll know who is, and I'll make sure that you get those. And then also refreshments are on the back right. And thank you to the city of Johnson City, I think, for refreshments. And also thank you to ETSU and the city of Johnson City for arranging and allowing this room. This session is going to be recorded. And so I'll probably, I've got two microphones going here, one for the recording and then one so you guys can hear me. I'm not going to move around a whole lot because of the recording, but when questions come, I'll try to remember to repeat the question and then repeat the answer if I can. And that's for purposes of the recording. The recording is going to be up on local government websites. So you can watch this at your leisure if you missed something today. I'll also put up contact information for each community, and you'll be able to see that at the end. So with that, I think we're ready to get started. Any local government, anybody need to add anything to what I just said? No. Okay, great. Okay. So we're here to talk about stormwater quality design. In particular, we're here to talk about post-construction stormwater quality design. I'm not going to spend a whole lot of time on erosion and sediment control. You've been doing erosion and sediment control the way the state wants it done for quite some time now. There may have been little tweaks to the ordinances in terms of erosion and sediment control. Those tweaks primarily were to align that ordinance with the Tennessee Construction General Permit. So if you've been working under that Construction General Permit for the past several years, I think the latest one's been out since 2021, then more than likely you've been doing everything that was related to those tweaks in the ordinance that has to do with construction site stormwater. What we're really going to dwell on today is post-construction stormwater or permanent stormwater management in terms of the design of the features and the compliance required to do post-construction stormwater quality in the way that the state of Tennessee wants to see it. So we have an agenda. I'll give you some background on why these changes have been made, give you an overview of general overview of an ordinance, how it's set up and how it relates to the water quality SCM manual. I'm not going to go through each jurisdiction's ordinance in particular. They're very similar in terms of stormwater quality requirements. They do have some differences in terms of the process of development in each community. So what I'm going to try to stick to today is what is similar. And if you have questions about a particular community, we do have representatives from each city here today that can hopefully answer your questions. We'll talk about how stormwater quality treatment compliance has changed, and it has changed a little bit. And that has caused a little bit of a change to channel protection requirements as well. And I'll talk at length about those. We'll talk about some changes that the state wanted to the vegetated water quality buffer requirements in each community. Again, that's a permanent buffer, not your construction buffer. And then we'll have time for questions. We'll also have time for cities to speak. I think right now I know that Johnson City's going to speak, but again, we have representatives from each community, so if you have a question, we'll try to answer it the best we can. I'm fine with questions throughout. I do have a stopping place kind of after each module for questions, but if something comes up and you want to ask a question, just raise your hand and I'll be happy to stop at the time and give you an answer if I can. Okay. So why are the stormwater quality rules changing? The main reason really is that a municipal storm sewer system, or MS4 permit, that all 4 of these communities and 90 plus other communities in the state of Tennessee has changed at the state level. That MS4 permit, one piece of it has to do with post-construction stormwater management. And if you've been aware of that permit at all in Tennessee, you know, that piece was in the permit since 2003. Around 2008, the communities here in this room, 2007, 2008, they passed their stormwater quality ordinance, or the piece of that ordinance that has to do with stormwater quality post-construction, that required 80% TSS removal. Well, since that time, we've gone through several state municipal separate storm sewer system permits, and the post-construction piece of that permit has been under appeal or under discussion or under change. And so things haven't changed at the state level since about 2008. So we've kind of floated along, and in 2021, the state finally got through its appeals, its lawsuits, and other things that were related to permanent stormwater management. And they finally put out a permit that had very prescriptive requirements for post-construction stormwater quality. An MS4 is really the public storm sewer system. So the public stormwater system that is operated by each community or their utility is the MS4. So if water from your project discharges to the MS4 or directly to a stream, then post-construction water quality may be something that you need to do. Most communities, I think, have a threshold of 1 acre or more. That is the threshold that's in the permit. Some communities do have a smaller threshold for doing stormwater quality. But if you discharge stormwater to a stream or local water body or the MS4, you've got something more than likely to do with stormwater quality. The permit at the state level regulates the discharge of municipal stormwater coming out of that system into local waterways. And so each of these communities has a permit to discharge non-point source stormwater coming off of streets, roads, properties, through their system and into a local waterway, but that permit requires stormwater quality management, and that's why we're here today. So the 2022 permit included rule changes that bring us to this point here. Those rule changes had to do with new developments and redevelopments that were an acre or greater of land disturbance. The deadline that TDEC set for the municipalities was September 1st to make those rule changes. I'm not sure that everyone met that September 1st deadline exactly, but generally those ordinances have been revised, have been adopted, and as of that adoption date, any plans that you submit after that adoption date need to meet these new requirements that I'm going to show you today. Okay, so it might not be September 1st in every community. Consult the community's ordinance or the community itself, and they'll let you know. So the objectives of a stormwater ordinance in general are really to establish the local authority and the project applicability for who needs to manage stormwater, okay? So you're gonna see what projects are applicable to these requirements, what land disturbances are exempt. The ordinances also adopt by reference any other guidance or policies or things that are not placed in the ordinance. They adopt those by reference through other means. And so those are named in the ordinance. All of the ordinances for the jurisdictions in this room adopt by reference the Tennessee Construction General Permit. That most of them pretty much refer to the permit for your erosion and sediment control requirements. They refer to the Tennessee Erosion Control Handbook for how to design those erosion control measures. And then they also refer to the local SCM, Water Quality SCM manual, the one that's been revised for stormwater quality and channel protection requirements. And your ordinances may also reference other manuals like public works standards or other handbooks or localized standards for other things as well. So that's the purpose of an ordinance, is not necessarily telling you how to do everything, but telling you what you need to do and where you need to go in order to make sure that you understand how to do it. The ordinance also establishes the local controls that the community itself uses to gauge compliance with the conditions of the ordinance and its reference manuals. So those are things like requiring erosion and sediment control plan, requiring a SWIP, requiring a water quality management plan or stormwater management plan, having a grading permit or any other kind of permit. So those are the controls that a community uses on the front end to make sure that what is designed for a project is designed in compliance with the ordinance and its reference manuals. And then again on the back end, through controls like a record drawing, engineering and surveyor certifications, things like that, those are the controls authorized by the ordinance to allow a community to look on the back end that what has been constructed in the field or installed in the field does in fact match the approved plan. Those controls, or the ability to gauge compliance in those ways, are all required by the MS4 permit. So even in communities that prior to today did not require as-built plans or record drawings, I guarantee you in Tennessee they're probably going to require them now, because those are a required element of the MS4 permit that came out in 2022. Okay, if the community is a permitted MS4, more than likely you're going to have back-end requirements now that assure construction termination in compliance with the approved design plan that you put forward. Ordinances also identify the overarching stormwater requirements that different projects, that are applicable to different projects. So if you have a project greater than an acre in Johnson City, you're going to look in their ordinance and you'll see that Johnson City says, yes, you have to do stormwater quality, yes, you have to do channel protection, and unless we waive it, yes, you probably have to do detention. So those are the requirements that I'm talking about. They're overarching requirements, and typically an ordinance will say you have to do stormwater quality, go check out the manual and it'll tell you how to do it. So it's authorizing and imposing that requirement on you. It's not giving you all the details on how to make that compliance happen. And then finally, importantly, ordinances establish the enforcement mechanisms in case of failure to comply with the ordinance. Those are also required much more prescriptively by the 2022 MS4 permit now. So you may see a few changes on the compliance side as well. When you look at a stormwater manual, that's where, whether it's the water quality SCM manual or public works standards or what have you, that's where all the methods, calculations, equations, design specifications really are going to be. So it's really going to explain what those design performance standards are. So what's the measuring stick that, what's the measurement you have to meet? It's going to explain or reference the hydrologic methods and hydraulic methods that you need to use to do that. This water quality SCM manual doesn't provide a lot of typical engineering methodology, such as how to do the NRCS runoff hydrograph generation. You know, this manual assumes, like many other manuals, that as an engineer you can go to an engineering text and learn how to do that. It does, however, provide you some information on stormwater quality volume calculation. That's typically not in an engineering text. That's not something we all learned in engineering school. So it will establish minimum specifications for the design of stormwater control measures, SCMs. I'll talk about SCMs a whole lot more in a minute. It also talks about some helpful low-impact development practices and local incentives that are coming soon for those practices. Low-impact development practices from a stormwater perspective are ways that you can reduce the generation or reduce the volume that flows off of your site through site design planning measures and infiltration or capture and reuse practices. We'll talk about those a little bit more in a minute. And then the manual also provides checklists for the development of your plans. It provides a narrative on, you know, what to provide, how to provide it, what scale, things like that. So you'll find all of those things in the manual. The new water quality SCM manual is simply a revision of the old water quality BMP manual. So the states changed our terminology. A BMP no longer refers to a post-construction stormwater measure. The terminology stormwater control measure now refers to post-construction stormwater facility that you put out in the field, okay? So it's a stormwater quality SCM manual. It deals only with water quality and channel protection. It does not address detention, okay? And it's got the same table of contents that it had before. We revised only the sections that needed revision, as well as updated the SCM design requirements. So what, you know, how the design specifications you had in the past on how to design an extended detention pond or how to design a bioretention area, we've gone all the way through all of those and updated those to account for the knowledge that we have all gained over the past 15 years in terms of water quality design. So still the same manual. You'll find it on your local websites, local government websites. So the typical regulatory framework for local stormwater rules is you have a city code of ordinances, and then whether they parse it out by chapters or titles or what have you, you've got various pieces of that ordinance that deal with erosion and sediment control and the permitting associated with that, that then lead into post-construction stormwater management and water quality buffers. A lot of times, let me see, I've got my handy dandy, good. A lot of times the permitting will be cited close to the erosion control section of the ordinance, but will have an overarching requirement for that permit. That permit, usually it's a grading permit or a land disturbance permit, is typically the permit that then leads into your permanent stormwater management and your buffer requirements. So for, I think, every jurisdiction in the room, you're just getting one permit, land disturbance or grading, but under that permit, you're typically satisfying requirements in all three of these areas, okay? So the ordinance tells you what is required, and then your reference manuals, whether it's the construction general permit and the erosion sediment control handbook at the state level, or that water quality SCM manual, that's going to tell you how to comply with the stormwater quality pieces of that ordinance, okay? Now, as far as local design standards, this table was in the old water quality BMP manual. It's the same table that's in the new water quality SCM manual. So stormwater quality treatment for these 4 communities has been 80% TSS removal of the water quality volume since 2007, 2008. That has not changed. That standard is exactly the same. We read that very well. The state went after that standard, and that's now the state standard, 80% TSS removal. Downstream channel protection has been the runoff volume from the 1-year 24-hour storm event, extended detention of that. That has not changed. And then your detention and your extreme stormwater management requirements will vary by jurisdiction. Just go to the ordinances and the local standards, and they'll let you know what those are. So this kind of bullseye graphic was in the old manual. And it really was talking about how if you choose to, you can nest your design compliance into a single SCM. That is still true. It's not necessarily always the way you're going to go, depending upon the project and what you want to do. But the volume that you control for stormwater treatment can also account for some of the volume that you deal with for channel protection. And retaining those volumes can also be situated into your detention feature for flood control and extreme stormwater management. So that has not changed. One of the things that has changed under the new state permit is that the stormwater quality treatment volume changes depending upon the SCM that you decide you're going to use to control stormwater quality. Okay? Used to be, we just managed 1.1 inches or thereabouts, 1.1 inches. Typically that would be done through an extended detention pond with a water quality orifice and maybe a grass channel upstream of that to get your 80% TSS removal. That is what's changing in this new manual is the amount of volume that you have to control and the way you show compliance for that control. So let's get into that. We'll talk about stormwater quality treatment and channel protection standards. Some terminology, probably should have put this one at the start. Post-construction or permanent stormwater management is the removal or control of pollutants from stormwater after construction is complete. So construction's done, that business or that residential area is occupied now for whatever it was created to do. We still have the requirement under Tennessee state law and under their permits to control stormwater quality from the smallest volume of water, okay? That's called the water quality treatment volume. Total suspended solids, or TSS, is the parameter that the state chose to be an indicator for the reduction of pollutants in stormwater. That has been the indicator that these 4 communities have used since 2007, 2008. And the water quality volume is the required volume of water that must be controlled for stormwater treatment, okay? That's not changed. The amount of what that volume is has changed. We'll go through that. As I said, stormwater control measure is now what we call the permanent stormwater quality facility that's on site. Best management practice is still a term that's out there. BMPs can be either erosion and sediment control measures, BMPs, or when you're talking about permanent stormwater, you may have, for a special pollutant site, maybe you've got petroleum, things like that on your site, fuel containers. A BMP would also be a measure to control or not expose those special pollutants to stormwater when it rains, okay? So BMP now is changed a little bit to either stormwater control, erosion and sediment control, or kind of a no exposure or a point source control, a dumpster cover, a enclosed trash facility, an enclosed transfer facility, things like that, okay? So before I tell you about the new way, I want to remind you about the old way. For stormwater compliance, the old method, our performance standard, was 80% TSS removal of pollutants from the water quality volume. So removal of TSS from the water quality volume. And we had this equation, the water quality volume equation that we used, where P is the rainfall depth or precipitation depth. That was 1.1 inches or thereabouts. RV is a factor that has to do with the imperviousness of a site, so that it's kind of like a curve number, or a C factor in the rational method was your RV. I in the RV equation was your impervious percentage over the whole site, okay? And then impervious percentage in the SCM drainage area. And A was the drainage area to the SCM, okay? So if you had 2 SEMs on a site, you would work this out twice, one for each drainage area, where area A would be the drainage area to SEM1 and SEM2, and I would be the impervious percentage of the drainage area to SEM1, and then impervious percentage for SEM2. So that was the required volume you had to meet. And then you designed SEMs, or then BMPs, to control that volume of water to 80% TSS removal. And so what that looked like would be, let's say, an extended detention pond that controlled that smallest volume, that 1.1 inches of rain, the water quality volume. That extended detention pond got you maybe 60% TSS removal. So more than likely you had to put a grass channel or something upstream of that to get you to 80% TSS removal. But your pond profile tended to look something like this, where you had water quality volume, channel protection volume for the 1-year storm event, and then your detention volumes all up the riser, okay? So some of that has changed. So as of September, that design standard of 80% TSS removal of the water quality treatment volume is the same. Most of the SEMs that were in the old manual are now in the new manual. Things that you're not going to see are things like grass channels. And I'll explain why that is in a few minutes. And then a lot of the policies that were in the water quality SEM manual have stayed the same. You know, as I said, the design specifications have changed a little bit, but by and large, I think you're going to see that they're pretty much the same. The checklist, all of those things are still in there. What's changing is the rainfall amount that is required to calculate that water quality treatment volume. There is a new calculation method in addition to that water quality volume equation for determining the water quality volume. There are new policies for what we used to call proprietary BMPs. They're now called manufactured treatment devices. And there are new requirements for SEM treatment trains if you get to the point of needing to put in a treatment train. Most of you, I think, will not get to that point. So the main table that you're going to be looking at in the new manual is the SEM treatment table. And the SEMs are now divided into different groups. There's 4 different groups, and each group has a different treatment mechanism, so how it treats stormwater quality. So group 1 treats stormwater quality. These are the true green infrastructure or low impact development SEMs, where you've got infiltration, evapotranspiration, or rainfall harvesting and reuse. So things like a cistern or a bioretention area without an underdrain. What you're doing is capturing that water quality volume and you're not allowing it off the site. That's group 1, okay? Group 2 is still green infrastructure, still considered LID. It uses biologically active filtration, but it has an underdrain. So this would be a bioretention area where you don't have the capacity or you don't have the soils to infiltrate. So you're going to biofilter and evapotranspire that water in the bioretention area, but that water quality volume that you treated is going to go out through an underdrain to the storm sewer system. So it's cleaner water going out, okay? Group 3 is sand or gravel filtration and settling. So something like an extended detention pond. It settles out the TSS as the extended detention progresses. And you've got cleaner water coming out the end of that pipe for the water quality treatment volume. And then finally in group 4, you have hydrodynamic separation manufactured treatment devices. So things like swirl separators, baffle separators, things like that, okay? So you read this table by column, but also by row, okay? So you probably, as a designer, you're going to say, well, I want to use, a dry extended detention basin. So for dry extended detention, I'm a group 3 SCM. I'm operating by settling. So my water quality, my minimum water quality volume for 80% TSS removal is calculated based on the first 2.5 inches of the 1-year storm or 75% of the total runoff volume from the 1-year storm. So if you look in this column, you can see that the 1-year storm is now the design storm at the state level for stormwater quality management. They've gone ahead and said, we have a design storm, it's the 1-year storm. And depending upon the group that the SCM you've chosen is in, that will tell you the volume that you have to meet to treat 80% TSS removal. So you read this across. If I choose a bioretention area with an underdrain, I'm group 2. That means I need to control the runoff volume generated from the first 1.25 inches of the 1-year storm. Okay? So if you read this table, each row gives you 80% TSS removal. Okay? So now if you pick a dry extended detention basin, as long as you size it to one of these two choices for the water quality volume, then you're meeting 80% TSS removal. You don't need to do anything else for water quality. Okay, so you read it by row. Each row constitutes 80% TSS removal. The water quality volume and the type of SCM, that's what is varying. Okay, so looking again at the old method, you know, the old way since 2008 of doing this, we would have put that dry extended detention pond and sized it for 1.1 inches, but that didn't give us a total TSS removal of 80%. We had to put something upstream of it, so maybe we chose a grass channel or a hydrodynamic separator or something like that. We also sized that for that same water quality volume. We put these in series, and out the end, you had 80% TSS removal. That's not the way to do it anymore. What you do now is you size that dry extended detention pond for the water quality volume of 2.5 inches of rainfall or 75% of the volume from the one-year storm. And you've got 80% TSS removal. Okay, you don't have to stack and treatment train anymore. However, if you decide that's a bioretention area and you want that instead of an extended detention pond, then you only have to control the first 1.25 inches to get 80% TSS removal. Now, you still have to do channel protection and your detention downstream of that bioretention area, but in your detention pond that's downstream, you don't have to worry about the water quality volume. You've already dealt with that through your bioretention area. Okay? Does everyone understand that? That's the big change. It takes a little getting used to because you're used to thinking of trying to get 80% by finagling your SCMs. And now you just choose one SCM, and if you can size it properly and design it according to the manual, you're good to go. So this takes our old extended detention pond profile, and it does change it because we have a lot more water now in an extended detention pond that we're controlling for water quality volume. Okay, now the reason that, I'm going to back up a little bit, the reason that TDEC did this is because not all SCMs are created the same. They're not all as efficient as each other in removing pollutants from stormwater. And so the SCMs in a group 1 situation where none of the water quality volume is running off site, that's the most efficient. You've got 100% pollutant removal basically there because that volume's not going off site. In group 2, they're very efficient, and so you only need to do 1.25 inches and you get that 80% TSS removal. As you drop down to groups 3 and 4, these are a lot less efficient. And so instead of dealing with different pollutant removal percentages, what TDEC did is say, okay, we'll just make you control a larger volume so that when you control a large volume in a less efficient SCM, it's equivalent roughly to controlling a small volume in more efficient SCMs. Okay, so that's what TDEC was thinking in order to come up with this scenario. It just kind of flips it on the head of how you get to 80% TSS removal. Okay, so you still have the option of using that water quality volume. That does have a name, by the way. It's called the simple method. And the changes, it's kind of hard to see, but the changes here in red. You use the rainfall depth from the treatment table to determine your P, your precipitation depth, okay? The RV is still the same, the imperviousness is still the same. One thing that the permit does and that the new manual does is encourage you to try and keep your drainage area to the SCM 100% impervious. So on a commercial site, that tends to be easier to do than on a residential subdivision, of course, because you've got a lot of intermixed stormwater coming off pervious and impervious areas. But if your imperviousness or your drainage area can be confined simply to impervious area, then your imperviousness is 100%, and the equation works out a little bit easier. But that is also a change that the permit allowed, is just to control the impervious surfaces on your site from stormwater quality perspective. Now, as an engineer, if that SCM is receiving stormwater both from pervious and impervious areas, then that equation needs to include the pervious and impervious areas, because it needs to be sized from a water quality perspective on up through detention. It needs to be sized for the drainage volume that it's receiving. Okay, so if you have pervious area going in, make sure that that pervious area is reflected in this equation, right? An example of that, we have a very simple development going on here, an office building and a parking lot. And I'm just going to say, for example purposes, I can get everything over to a bioretention area that's here. I'm not running off any pervious area. So my area is 2 acres. I have 100% imperviousness, so my RV is 0.95. I've selected that group 2 bioretention area. I'm going to say it has an underdrain, so I know that I need to calculate my water quality volume based on the first 1.25 inches of rainfall. I stick my 1.25 inches into that equation. We're not really dealing with the first in this method. Remember what it said was the first 1.25 inches of rainfall. That's where the simple method kind of breaks down, is it will be the first amount of runoff that you see, but it's technically, we're not dealing with the timing of the stormwater here. But I've calculated my water quality volume to be 0.2 acres, okay? Another thing that we've been doing all along when we use that simple method is we have to make sure that we understand what the water quality peak discharge is, the QWQ parameter. That's been in the manual for a long time, but I've heard from a lot of engineers that didn't realize they had to do that. You do have to do that. You have to determine the peak flow from your water quality event, or the peak flow from that water quality volume, so that you can size the different flow diverters, outlets, inlets, things like that for that SCM and the water quality volume. You'll need to also route that peak flow through the SCM, the smallest portion of the SCM, to make sure that it's not going to get overwhelmed for your water quality volume. So there is a full calculation method in Chapter 3 of the Water Quality SCM Manual. It's not changed from the method that was there previously. I just wanted to point this out and make sure that you are aware you need to determine the water quality peak flow and make sure that your SCM is sized for that peak flow, okay? Even if it's an offline SCM, it's got to be able to handle the water coming into it, okay? There are more equations than just that one. That's the ending equation. But if you go in the manual, it'll show you how to come up with all those parameters. Okay. There is a second method to determine the water quality volume and the water quality peak flow. This is a method that you're all familiar with, the NRCS hydrograph method. So you're going to do your typical NRCS hydrology, finding curve numbers, a time of concentration, etc. Your design storm is that 1-year storm. You have to use the latest NOAA precipitation frequency atlas. It's number 14 right now for that data, okay? In Johnson City, for all the other storms that you're controlling, you're going to use technical paper 40. But for all the other jurisdictions, let me back up. In Johnson City, you have to use NOAA for the water quality treatment volume, but technical paper 40 for all of the other design requirements. In the other communities, you're using NOAA, or they'll let you know if there's something different. But the state mandates that the NOAA rainfall distribution or the NOAA rainfall information be used for the water quality volume, okay? You're going to get that rainfall depth from the SCM treatment table for the selected SCM that you have, and you'll use the hydrograph that's generated to determine your water quality treatment volume and your peak flow. So using that same example, the design professional is going to go ahead and develop their required NRCS parameters, and then we'll just plug that into our software using the NRCS TR55 method to come up with our runoff hydrograph. I'm going to say we've gone ahead and chosen that same bioretention area with an underdrain, a group 2 SCM. So we need to find the first 1.25 inches from the 1-year storm. Here's our hydrograph for the 1-year storm. And I know it's a little hard to see because you're far away, but the first 1.25 inches occurs, I can't even read it here on my screen. It occurs between, I think, 10 and a half and 11 hours. I think that's what that says. So I've interpolated just to find where that 1.25 timing is, right down there. So the volume under that tiny little slice is your water quality volume. The peak discharge is the peak right there. So that's the flow that must be routed through the SCM and used to size diverters and things like that, okay? The design specifications that are in your manual will tell you how to size what, okay? So when the water quality volume passes, the timing of it passes the peak of the 1-year storm hydrograph, then the volume under that larger area is the water quality volume, and the peak of the hydrograph is what must be routed, okay? So it just depends on what's going on your site to know whether you're past peak or before peak. But you have to pay attention to whether you're past or before in order to understand what your water quality peak flow is, okay? So this is, this is the way that TDEC prefers. We allow both ways in these communities. Just know that if TDEC ever were to get involved, they'd probably want to see this. I don't know why that would be, but. Now, one thing I want to point out, you've probably already noticed, Group 3 SCMs, so extended detention ponds, permeable pavements, sand filters, wetlands, your storage features, they're all considered Group 3 FCMs, and you have a choice. You can either design that for the first 2.5 inches of that 1-year storm or for 75% of the total volume of that storm. Just do whichever you prefer. Typically, that's going to be whatever is less. So again, let's say you chose to use 2.5 inches and it comes out with this. You've got that volume that you need to determine for the water quality volume and then the peak flow. But let's say you decide to use 75% of the 1-year storm, then you're going to get the volume, the total runoff volume under the hydrograph. So all of that, but just multiply it by 0.75. So 75% of that volume then is your water quality volume. Right. Now, a little give back that you're getting from the Tri-Cities communities here in the room is that they recognize that the volume you're controlling, especially since you're working with the storage features here, like a stormwater wetland, you can do from water quality all the way up to a 100-year storm in an extended detention pond, a wetland, a submerged gravel wetland, all of those storage features. By the time you've done water quality volume, you're about as close as you're going to get to your channel protection volume. It's very, very close in size. And so if you're doing a storage feature to handle water quality volume and you've got that capacity, they'll just call it even and you've met your channel protection requirement for that particular SCM, okay? If you're using any other of these SCMs or ones that are not in a box, they won't do channel protection for you, so you've got to do channel protection down in your detention pond, okay? All right. There's a couple other key changes. The first one is that Group 2 SEMs. So these are the green infrastructure SEMs that do have an underdrain. And I would suspect, because of the propensity for sinkhole formation in this area, most of the time if you're doing an infiltration SEM, you're going to have an underdrain. It's a matter of safety. So more than likely, if you're going to want to do green infrastructure, you're going to be in Group 2 more often than you're going to be in Group 1, I suspect. But if you choose a Group 2 SEM, TDEC requires at least 12 inches of internal water storage in that SEM before it's discharged, okay? That creates an anoxic zone that helps with pollutant management, particularly nitrogen and phosphorus management. I know those aren't the pollutants that we're controlling here, but this is the requirement from the permit, so these jurisdictions have to pass this requirement on. So anything that's a Group 2 SEM has to be designed with at least 12 inches of internal water storage, and so that underdrain needs to be configured for that. There are probably more underdrain configurations than what I'm going to show you here today, particularly manufactured treatment device vendors may have some inventive ways to do this. But if you're constructing a bioretention area yourselves, underdrains, there are typically two general ways to provide that internal water storage. The first is with an upturned elbow underdrain. And you see you've got the perforated pipe down at the bottom in its stone jacket. There probably is some infiltration going on, but it's minimal. If you're in a sinkhole area or an area with pollutants, more than likely you're going to have an impermeable liner anyway. But that underdrain sits at the bottom, but it has an upturned elbow right here. And so it's not going to actually drain until you get this water storage, until water storage rises to the invert of that elbow, okay? So it creates this minimum of 12-inch internal water storage area that just sits in there until the next storm, or if there's not an impermeable liner here, some of it will infiltrate, okay? So there's an upturned elbow underdrain configuration. The other configuration is an elevated underdrain, where you've just elevated the perforated line at least 12 inches off the bottom, and there's a stone reservoir down here. A lot of people will call that an infiltration sump. If there's no impermeable liner at the bottom, it will infiltrate. Some of it will, some of it might not. But when the next storm comes through there, the thinking is that that will churn and refresh and cleaner water will go out the end, okay? So those are the two main options for underdrains that are described in the manual. It's in the design specifications of the manual. And then I wanted to say a little bit about underground detention basins. There are conflicts in the manual that's currently out there on what an underground detention basin can do in terms of stormwater quality. Really what I want to say today is just understand that right now an underground detention basin is listed in this table as an SCM. I'm not sure that that will remain. Nobody wants to prevent underground detention basins from going in, but there is a lot of talk in the stormwater quality world about how much stormwater quality they actually can provide. So you've got open basin concepts that a lot of vendors can sell, but these are typically put on a compressed or a compacted pad. And over time, they're going to have some sediment come into them. So their infiltration capability over time is pretty suspect. If you do extended detention designs, I've got a number of manuals that I've seen that are very concerned about sediment resuspension because the splashing around and the washing in the underground basin can resuspend sediment and just send dirty water out the end. So there's some discussion that needs to happen with the local governments between me and them, and we'll figure that out and let you know when there is a revision to that manual that deals with this. My personal opinion is the preferred use for a detention underground basin is for detention, and then there are small footprint SCMs that can be put just upstream of that basin that you can deal with your water quality volume on. So that's not in the manual. I'll talk with them and it'll be revised. So just know that that's a conflict in the manual right now. SEM treatment trains. An SEM treatment train is when 2 or more SEMs are placed in series. And given what I've just told you about how compliance is seen with just you choose one SEM and size it properly, you get 80% TSS removal. I don't know that a lot of folks will need to use SEM treatment trains anymore. But if you don't have the capacity in your SEM to do water quality, that would be one reason where a treatment train would come in place. So you would share the volume, that total volume that you need to get the capacity for 80% TSS removal. Maybe you don't get TSS, if you don't have the capacity, you're definitely not going to get TSS removal. So again, that's why you would use a treatment train. There are new rules surrounding treatment trains. The rules have to do with whether there is an MTD, a manufactured treatment device, in that treatment train or not. So all of that is in the manual. It's in both Chapter 3 and in the design specification for manufactured treatment devices, okay? So just know that if you're inclined to go down the road of SEM treatment trains, to keep an eye on the manual because there are some new things that you need to be aware of. Water quality volume pretreatment, it is required for most SCMs, and this is a table that's in the manual in the design specification section that lists the SCMs and what types of pretreatment are allowed for each SCM. And just know that for storage SCMs like a dry extended detention basin, a wetland, a water quality basin, that pretreatment must be done via the state requirement using a sediment forebay. So you can no longer pretreat for a detention pond with a hydrodynamic separator. You have to use a sediment forebay. That is the state's requirement for those particular SCMs, okay? And the exception I put, maybe underground detention, we'll just have to work that out. That's because of that conflict, that's why I said there's an exception there. Just wait for us to catch up with that and we'll let you know. So that was my discussion on stormwater quality compliance and channel protection. Are there any questions? Not too bad. All right, I'm going to move on to manufactured treatment devices. So here we have that SCM treatment table again, and I want you to notice that there are manufactured treatment devices in every group, okay? So no more are we just referring to hydrodynamic separation. We've got filtration MTDs that are in group 3, biofiltration MTDs in group 2, and things that infiltrate without an underdrain in group 1. I personally have not seen a group 1 MPD, and I've talked to a number of MTD vendors, and they haven't seen that either. So I imagine they'll come out someday, but group 1 doesn't currently have any MTDs that are certified. I'll get into the certification in a minute. Group 2 MTDs, you've probably seen these kind of Filterra or tree boxes that are out there. These are really pretty nice features, and they work by biologically active filtration. There's plant uptake, evapotranspiration. They've got engineered media, and the media will biofiltrate the water that comes through them. Just remember that you need to, because they're a group 2 SCM, you need to have that 12 inches of internal water storage. So just work with your MTD manufacturer or vendor to provide that. I know they can do it. That doesn't seem to be a problem for them. And the nice thing about pretty much every MTD is they come with all the required components. The required components being, they all have an inlet. So here, this may be water that comes off a street gutter into an inlet and then into the unit. Water can also get down through this grate here. They have pretreatment, number 2 there. Water that comes in is typically pretreated within the unit, so you don't have to design anything else. There is the treatment area, and for a group 2, that's an engineered media. There is an outlet, and there is a bypass for higher flows than the water quality peak flow. Okay, so this would all be designed for the water quality volume and the water quality peak flow, and then what is sent out of it, whether it's bypassed or treated water, goes to the stormwater system and the detention pond that's downstream. Okay, here's another type of Group 2 MTD. It's a very similar concept, just different plants. Water enters through a curb cut or a curb inlet or through the top. It gets pre-treated. Here's a baffle box, gross solids and a litter box that catches the pre-treated water, goes through the engineered media. There's an outlet. There is also a bypass overflow. Okay. So those are Group 2 MTDs. Group 3 MTDs they physically remove pollutants. So that's what we're looking for in a Group 3, whether it's by settling or filtration. It's physically removing the pollutants that come in. You're probably familiar with these. These are like cartridge filter units, and the wrap on the unit is what filters the water. There are also the kind that within the unit there is a media that is tailored to the type of pollutant that you're trying to capture. So there's different types of media, and by the time the water goes through the filter, the white filter, and through the media, then cleaner water comes out and goes out the rest of the system. So those are Group 3 MTDs. Then Group 4 MTDs are the ones we all know and love, the hydrodynamic separators. Again, these MTDs, just like Group 3, Group 2, they have pre-treatment components. They have inlets, outlets. They should be able to be designed to handle all the flows that are intended to go through there. Okay. So the key policy for MTDs, and I think some of the jurisdictions in this room had this policy already, but now it's official at the state level, is there needs to be some kind of industry-wide certification of pollutant removal for the MTDs. And since the New Jersey Department of Environmental Protection has been doing this for a while, that is the certification that we're looking for these 4 cities that are in the room today. So when you use an MTD for primary treatment, it is your primary treatment SEM, it needs to be certified at 80% TSS removal from NJDEP, okay? Now, NJDEP certifies MTDs at either 80% or 50%. And unfortunately, the 50% are all the hydrodynamic separators. So if you want to use a hydrodynamic separator, right now, there is not one out there that gets 80% TSS removal. So you're welcome to use it for pretreatment, but you're going to need another SCM, whether it's in a pretreatment treatment train or you're just using it for pretreatment upstream of, say, a bioretention area or something like that. Okay. The design flow must be no greater than the maximum treatment flow rate that's cited in the NJDEP certification. I'll show you where that is in a minute. So key policy has to be NJDEP certified if it's your main treatment SCM. This is a screen capture of the NJDEP MTD certification website. They have separate tables for green infrastructure MTDs, and these are all Group 2 MTDs. They have some sort of an underdrain and biofiltration system. And then Group 3 and 4 MTDs are called MTDs not considered green infrastructure by NJDEP, and there's a lot of them. I don't even have them all on the screen here, but there's a ton of them that are certified. You can see the certification here, the pollutant removal percentage here. And so there's a few key elements. What you do is, let's say I'm going to pick this focal point high performance modular biofiltration system. I would click on this certification right here, and that will bring up the NJDEP certification letter. Looks like this. On that letter, it gives you the TSS removal rate, it gives you the maximum treatment flow rate, and it also gives you some guidance on sizing, okay? So if your maximum treatment flow rate exceeds what's cited here, then you need to move to a different MTD. Could be another hydrodynamic separator, could be another biofiltration unit, whatever, but you cannot exceed the maximum treatment flow rate because that is what this 80% TSS removal is certified for, up to that flow rate, okay? The nice thing about NJDEP as well, so this letter will be given, you need to print out that letter or PDF it or what have you and turn it in with your water quality management plan to show that you've got a certified NPD. And the nice thing about the NJDEP website is almost all of the MTDs also have their maintenance manual up on that website as well. So typically when you see this, a lot of the things that say plan here, where it says plan, those are the maintenance plans. So you would click on that. There's your MTD maintenance plan, and you can just include that with your water quality management plan as well. Okay? So back to the policies. NJDEP certification is required for MTDs used for primary treatment, whether it's alone or in a treatment train. It is not required when you're just using an MTD for pre-treatment purposes. So if you've got an SCM that handles the whole water quality volume, say a sand filter, but you haven't designed that pre-treatment for that sand filter yet, you're more than welcome to use a hydrodynamic separator for that. You don't need MTD, or you don't need NJDEP certification. The MTD that is approved on the water quality management plan must be the same MTD that is installed on site. So if you need to make a field change, you need to go back to your local government for approval of that MTD substitution. And we know that happens. There is a method or a process for that happening, but the state requires local governments, permitted local governments, to make sure that their approved plan is adhered to. If it's not, it's a liability for the local government. So the local government is kind of passing that adherence down to you. Adhere to this plan. Where you can't, we want to know about it so that we can document we've approved the substitution. When you prepare your record drawing, you need to make sure that you're preparing it based on what's in the field and not what was in that original approved plan, especially if you've made a substitution when you're in the field. And then another addition, I think a number of you were doing this already, is that MTDs that are placed in parking lots with more than 100 parking spaces, or for land uses that have petroleum storage or could have petroleum issues, the MTD needs to have a minimum of 60 gallons of internal volume dedicated to storage. And that's to try and prevent petroleum products from getting out into the full MS4 system where it becomes a larger problem, okay? Any questions on manufactured treatment devices? And this is this is a manufactured treatment device. It's a packaged urban bioretention area. So there's a lot of new things out there that are pretty nice. Okay, well, I'm going to move on to vegetated buffers. An overview of the rule changes. So what's staying the same is that you still need to do a permanent buffer for the different water bodies that were cited before. So streams, wetlands, lakes, and ponds. I think in the past we used the terminology community waters. That terminology is gone now. We're just saying you need to do buffers for these water bodies. The width is still measured from the top of bank or the normal pool elevation, depending upon the type of water body you're buffering. You can do buffer width averaging. Those rules are all the same. If you have overland flow into that buffer, then it needs to be sheet flow, and there's a spec for a level spreader in order to gain that. And there are still restrictions on the use and activities that are performed in that buffer. And so as a designer, it's important that you understand those restrictions and uses so that you don't design something that would either not be approved at the local government, design approval level, or would put the ultimate property owner in a situation where they've got to remove something that you've designed in there if it's not caught at the local government level. So what's changing is there's a width increase for most streams, and we'll talk about that. And there are some revised rules for vegetation and allowed entry and uses. So the buffer width, it's got a purpose, and the permit talks about the purpose being additional water quality protection, stream bank and shoreline stabilization, and canopy protection or shading of the stream. That's what the MS4 permit that our local governments are complying with need to pass through to developments, new developments and redevelopments over an acre. So all water body types now have the same width requirements. In the past, we had a different buffer width for a wetland than would be on a stream. That's no more. They all have the same width requirement. The difference now is whether the water body being buffered has been designated by the state of Tennessee as having available parameters for siltation and habitat alteration, meaning it's got good water quality, or unavailable parameters for siltation and habitat alteration, meaning it's got poor water quality or it's impaired, the 404D list. It's an impaired stream. So if it's also an exceptional Tennessee water, meaning it's a very high quality water, they're treating that as in need of an additional buffer as well, because they want to keep it a very high quality water. So if you're good quality water, you're not listed on the 303D list, then you've got a minimum buffer width of 15 feet, but your average buffer width needs to be 30 feet. Double those for impaired streams and very high quality streams, a minimum buffer width of 30 feet and an average width of 60 feet, okay? So some of the communities here, I think we're at 50. We've gone up to 60 now. But you have to know the designation by the state, whether it's designated as impaired, exceptional, or it's not designated at all, to understand your stream width, okay? Width averaging is still allowed, but only in the outer zone. So if I'm buffering a creek that's impaired for siltation, I can't have a buffer that's less than 30 feet at any point. My buffer can be less than 60 feet as long as the average of the outer zone is 60 feet, okay? That looks like this. Let's say this is an impaired stream, and I've got my inner zone of 30 feet. You can see the width there, 30 feet. But I've got an office building, and I want to use as much of this as I can, so I've got an outer zone that needs to have an average of 60 feet for the whole buffer. So I bring it way out here and then push it in down as close as I can to that 30 feet, but not going on it. So the average of this buffer width is 60 feet through there, okay? That's how you manage the averaging. And this is what that might look like in a residential subdivision. And it's not lot by lot the average, it's the whole subdivision is the average that buffers the creek, okay? So these lots may have more buffer while these don't have any, except for the 30 feet behind the house, okay? Just like in the past, we want to minimize the impervious surfaces in the buffer. There are some allowances, certainly for utility pads, for bridge crossings, stream crossings, things like that, roadway crossings. Trails are allowed, sidewalks, but if it's paved, then you have to increase the width by the width of the pavement that you're putting in there, the trail. So say you put in a 6-foot width trail, you've got to add 6 feet to your average width, okay? The prohibitions in there are, they're consistent now for each of the 4 communities in the room here. A lot of these were already in there. We might have reworded for you, but we don't want things in there that are going to impair water quality. So things like a commercial kennel or a feedlot or parking. So when you're designing these sites, just remember that when you're in the buffer, you really don't need to be putting impervious area there unless it absolutely cannot be avoided. And if it can't be avoided, you need to talk to your local government about what you're doing. The buffer vegetation standards at the state level have relaxed. I think this is a good thing. In the past, it was, we want you to stay out of it completely. It's an unmanaged area, an unmanaged zone. Just don't disturb it at all. And now what the state wants is that the inner zone should have predominantly trees, okay? And the outer zone should be predominantly herbaceous vegetation. Grass, shrubs, and trees are allowed as well. But we want to minimize erosion. We want to shade the stream. Those are the things that we want to do. So we're no longer requiring you to keep a really woolly, unmanaged look behind your buildings. You can clean up those water quality buffers, make them an amenity, make them look nice. We're just looking for trees in the inner zone and herbaceous vegetation at the outer zone. So you can still landscape and all of that sort of thing. Anything else on buffers? Okay. So I've finished most of the information that I wanted to provide. If the local government representatives can stick around for just another 5-10 minutes, I'd appreciate it. But we're done. Thank you very much. Appreciate it.